In this module we'll talk about light sensors and transmissometers. So what is a light sensor? How do they work? Connecting them to the Arduino and creating a transmissometer that we can use underwater. Quite simply, a light sensor is a variable resistor that will change resistance depending upon how much light it is exposed to. Typically they have a dark resistance, so 100k ohm, 200k ohms, and a light resistance under full brightness under 1k ohms. They're simple two-terminal devices that would take the place of a variable resistor or potentiometer in a voltage divider network. Here's a picture of one, small device, and you can see the two wire terminals, and you have some photoconductive material on the top area there, and the two contact areas, and the more light that hits that photoconductive material, the more it will conduct, and the lower resistance you'll have. Less light, lower conductance, higher resistance. Down here at the bottom is a link from Adafruit, which is a great tutorial on photocells. You can follow that and get even more information about photocells. Now, connecting it up to the Arduino, again the simple voltage divider circuit. We've got our fixed resistor up on top connected to 5 volts, and then the junction between the photocell and that fixed resistor is connected to the Arduino analog input. And in here I'm showing this extended out to where you could take 3 wires out to the sensor, one of them for an LED or your light source, a common ground between the LED and the sensor, and the signal for the sensor to get back to the Arduino. Here's the connections shown on your proto board. Our light sensor that we have in our kit is a 3-terminal device. It has the 10k ohm resistor connected to the 5 volt pin, and then the sensor itself is between the fixed resistor and ground. You can see our little connections here with the sensor output going over to A0 on the Arduino. Don't forget to connect up ground and plus 5 volts. And then off on the side we show a 1k ohm resistor connected up to the 5 volt bus, and you can use one of your extension wires that have the pins on one end and sockets on the other to extend your LED, so you can move it around and you can take it in and out from in front of the photo sensor. Now, in creating a transmissometer, it's a simple device that will measure the amount of transmittance of light from one end to another. Real simply, we're going to do this with a straw that'll fit over your LEDs and your sensors, so you can try some straws. Most straws will fit over an LED just fine. Find one that'll fit over both the sensor and the LED. Cut about a 2-inch piece of it off, and then cover that entire straw with some black electrical tape to make it completely opaque. These sensors are sensitive enough that if you just use the plastic without putting black electrical tape on there, you will not be able to achieve full darkness. And what we're going to do for testing, we're going to use that straw as a light tube between the sensor and your LEDs, just so that we can eliminate any stray light sources. Now, to take this whole thing and put it in the water, you'll need to build a shield like the straw to insulate the detector from stray light sources. A light source positioned directly in front of the sensor, so you want to make sure that the two are aligned properly, all on the same axis. And you'll need to have an opening between the sensor and light source that allows the free flow of water between the sensor and the light source. And just a slit in a straw won't work. You'll need to do something that will allow for rapid water transfer and water transfer over the sensor area. And don't forget, when you're building this, we'll need to seal all the connections, insulate everything that is electrical from water, And the sensor itself, we can coat it with a very thin layer of silicone sealant with very little degradation in performance. Here are a couple of pictures of some commercial transmissometers, and you can see on this top picture the light sensor would be on the right, buried back inside that housing, and on the left you'll have your light source, and the sensors held together through these mechanical couplings there, and the water would flow in between the light source and the light sensor. On the left is a C-star transmissometer. We've got two different size openings, and again you've got your light source shielded, and then the sensor even in a deeper shield to keep any stray light from getting in. Now, in sampling the sensor, we can go back to one of our old programs and go back to module 4 and get M4 analog N1, save it as M8-light, and start modifying it. By now you should be able to modify it to put your own messages in there and display exactly what you want. Now what I'd like you to do is work with the LEDs, work with the different color LEDs, and see if you can see any difference. If each LED has the same response, you should see some differences between the red, yellow, and green, and note those and write them down. And when you can work on scaling, one of the things you know that your counts are going to go from 0 to 1023. With this connection that we have up, 1023 would be full darkness, and 0 would be full brightness. So you could scale that sensor value and then multiply it out so you get a value that runs from 0 to 100%. I have this as a separate note in this module, but I want to go over it just the same. You'll notice that in a lot of the Arduino sketches that are out there, they have the sensor as the high part of the voltage divider leg and the fixed resistor as the bottom part. In reality, it doesn't make any difference which is placed where if you're doing a dry sampling. But once we start putting sensors in water, it's important that we pay attention to how they're connected to the Arduino and the system. And looking here, we have the sensor connected. We have 5 volts going through resistor R1 out to the sensor. We have 5 volts going through resistor R2 out to the LED, and then both of those are connected to a common ground back to ground. Now, if either of these wires develop a short circuit, say between these two terminals or from here over to here, it'll short the sensor or short the LED, but the resistor on the inside here connected to 5 volts will act as a current limiter for us. And so the worst case that can happen is we will read 0 volts here at AD0, or the LED won't shine. Now if we turn that around and put the sensor up on the top leg and the fixed resistor at the bottom, again it'll work. We'll have a changing voltage here, everything will be fine. But if we develop a short circuit outside there, again one of the terminals aren't properly waterproofed or whatever, then look at this short from here to here. That ends up being a short from 5 volts through here to ground, which will immediately short out the Arduino and prevent it from working. Now if we say, well, we could put a fuse here, and so if a short develops, the fuse will blow. Most fuses that are a very small current also have some high resistance associated with them, and we don't want to put them into a sensor string. The resistor out there works as the best fuse in this case. And if we were to put a fuse in there, it could be that the very short time constant that it takes to cause that fuse to blow would be enough to reset and cause the Arduino to stop working properly. So we come back up here. This is the proper connection. This is what we want to do. Make sure that any 5 volts that are fed out there go through a series resistor if possible.